Alright, let us continue the discussion. Now, whenever alkynes react with water, the reaction is slightly different. The first step is very similar to that of Markovnikov's addition. So here alkynes, one of the double bonds will break and water will get added up according to anti-Markovnikov's rule. So there will be one double bond existing and one OH added. See, this class of compound is called enol. Why we call them enol? From alkene we take En, from alcohol we take ol. Okay, remember OH and double bond is attached to the same carbon. Now these enols are not very stable. So what they do, they undergo a kind of rearrangement reaction which we call tautomerism, and they form either aldehyde or ketone depending on the nature of the alkyne. Let us have an example. CH3 C triple bond CH. So when we add water across the triple bond, you can see this carbon 2 having no hydrogen and carbon C is having one hydrogen. So obviously OH being the negative part will get attached to this carbon and H will get attached to this carbon. So what we get is CH3 COH double bond CH2. As you can see here, both double bond and OH is attached to carbon 2, so we call them enol, and name of this compound is prop2 enol. Because 2, why 2? Because OH is attached to carbon 2. Now they undergo a kind of rearrangement. You see the double bond breaks, that is step 1. Then C takes up the H, that CH2 carbon becomes negative and takes up the H, and the bond between O and H goes in between carbon and oxygen. So there is a double bond formed between C and O. So here we get a class of compound which is a ketone. As I told you, the product may be either aldehyde or ketone. So out here we get propanone. This is the first member of the ketone family. This reaction also will be needed for you when we will be doing aldehydes and ketones. That is the third chapter of organic in your class 12 syllabus. So with this we come to the end of reactions which are common to both alkenes and alkynes. Now we'll take a few reactions which are specifically only for alkenes. The first one is oxidation of alkenes by KMnO4, aqueous KMnO4. Aqueous KMnO4, that is potassium permanganate, is known as Bayer's reagent, and this particular reaction we do in the lab also in the practicals. Now what happens, alkenes when they are treated with aqueous KMnO4, we get vicinal diol. What is vicinal diol? Two OH groups get attached to the adjacent carbons where the double bonds were there. So let's have a look. CH2 double bond CH2. Since we have taken aqueous KMnO4, so we are writing water. And KMnO4, all of you know, sir must have done excuse me, nascent oxygen. It's an oxidizing agent. It releases nascent oxygen. So what happens here? Both the carbons, they take up one OH. And this kind of, since two OHs are attached to the adjacent carbon, you can see we call them vicinal dihalides. Alright. Name of this compound is ethane 1,2-diol. Why is it ethane 1,2-diol? Here also you have to remember one rule. When we have similar functional groups more than once, then we retain the E of the alkane. Alright. And since OH is attached to carbon 1 and carbon 2, that's why we write 1, 2. There are two OH, so diol. The common name is ethylene glycol, which you must have encountered before. It is used as an antifreeze mixture in very cold places in the radiator of the car to bring down the freezing point of water. We have done a numerical also based on this in the chapter solution. So, why this reaction is important in the lab? You see, the KMnO4 has a pink color. Alright, KMnO4 has a pink color, and after the reaction, this product which is formed, it is colorless. So when pink color disappears after adding to a certain compound, it's just like addition of bromine. Alright, this also serves as a test for unsaturation. If after adding KMnO4 to a certain compound, the pink color of KMnO4 disappear, then we can say the given compound is unsaturated. Alright. The next reaction is very interesting reaction. It is called ozonolysis. Very, very important. When ozone reacts with alkenes, an addition product called ozonide is formed. The ozonide further react with zinc and water to form aldehydes or ketones having lesser number of carbon than the alkene. So we call them step down reaction. When the product is having lesser number of carbon than the reactant, we call them step down reaction. The overall reaction, that is addition of oxygen followed by zinc and water, is called ozonolysis. So let us have a look. We have taken ethene. Okay. We have taken ethene, we have added ozone. Ozone is a very strong oxidizing agent and it breaks both the bonds between carbon and carbon. So you can see we get a house-like structure without a ceiling where the carbon-carbon double bond is broken and 3 oxygens of ozone get attached to 2 carbons in this manner. This is called ozonide. Now this ozonide, when you treat with zinc and water, it breaks in the form of alphabet Y, and what we get here, since the alkene was symmetrical, we get 2 molecules of the same compound. H, you can see here H, C double bond OH. These two bonds, they join together forming a double bond. This side also H, C double bond OH. So 2 molecules of the same compound we get. But if it is unsymmetrical alkene, here you can see I have taken an unsymmetrical alkene. Here what will happen? When ozone will add the double bond, this double bond will disappear. And what we have here, CH3CH, CH3CH, then this side we have C, CH3CH3, and 3 oxygens get exactly the same way bonded as before, and then we break it. Now you can see, since the alkene was unsymmetrical, the products formed are also different. So here what we get? Here we get this one as the first product, CH3C. As I said, these two bonds will couple together forming a double bond and H. So this is an aldehyde group. So we get an aldehyde with 2 carbon, ethanol. And on the other side, what happened? Here we have CH3C, and again these 2 bonds will join together. I mean this and this will join together forming a ketone. So here CH3CO CH3, which is known as propanone. So you can notice here we began with 5 carbon, but the products are having 2 and 3 carbons each. That means each of the products having lesser number of carbon than the starting material. So we call them step down reaction. But you have to remember the total number of carbons in both the products should be same, sum total of the same. I mean, if you add them up, it should be the same number of carbon as in the starting material. That means finally no carbons are added, no carbons are removed. But each of the products will have lesser number of carbon. So this type of reaction is called ozonolysis. Very, very important. We shall discuss them again in later when we will do aldehydes and ketones. The last reactions of alkenes is polymerization. Poly means many. Look for the definition in the textbook. Polymerization means when small units called monomers are joined together to form a very long chain, then such compounds are called polymers and the process is called polymerization. So the simplest alkene we have taken ethene. Ethene, when is subjected to high temperature and high pressure and in presence of a catalyst, the double bonds of ethene break and each of the ethene molecules, the pi bond breaks, and so each carbon will have one hand free. So with this they can form a long chain by holding the neighboring molecule. So ultimately what we get is polythene. I think the name of polythene is not new to you. We are so much used to this using polythene. It's a polymer, and you know these polymers are creating a lot of environmental hazards because they do not get degraded on their own. They are non-biodegradable. Now here I would like to tell you something. When you write the structure of a polymer, this bond which we are writing, the bracket should cut the bonds. Okay, so that you need to be very, very careful. So here what happened, we have taken n number of molecules. When n is a very, very large number, maybe in thousands, this n comes here because all the ethene molecules, they join together to form a long chain. So I'll stop my discussion here today. and the properties of alkyne I'll give you in the next class together with the aromatic compounds.